Good day, people, welcome to the next lesson on solving of frames. As I said in my last lesson, I'm going to start at joint B. I've drawn it out there. And of course, if you remember, as I said in my first lesson in applied mechanics, this is just the joint here. Okay, I've named it A. Named it C. Some of you still want to name it fancy ways. R, B, C, A, B, C, X, I don't know. You confuse yourself and you confuse me. Just do it simply, okay? Remember, I also said the first time, A is very much far down below here, and C is very much down to the bottom right side here, okay? It's a few meters away, but you got to name it accordingly. So that's, remember, AB or force BA, AB, force BC or force CB, same thing. And don't forget to draw in the reactions which happening at the joint. Okay, we said there that VB is 25.90 kilonewtons to upwards, and HB is horizontally to the left of 20.56 kilonewtons. If you leave that out, okay, the forces in AB and BC is going to be wrong. Okay, right. So what's the next thing we do is we assume whether forces in the unknown members are tension or compression. I'm going to assume that AB, if I look at the structure, I'm going to say it is in tension, and of course tension is going away from the joint like so. And I'm going to assume that BC is also in tension like so. What's the next thing we do? Any forces which is not vertical or horizontal, we resolve them into their components. So that's going to be like so, and that's going to be like so. Okay, right. What's the next thing we do? We need to work out the angle here. So that angle there is equal to that angle there. Do you agree with me? Well, you should, yes. Okay, so that angle there is equal to that angle there. Okay, and from the frame, which is a right angle frame at the bottom there, you can work out the angle inside there. Okay, so stop the video, go back and do a bit of trigonometry, and you will see that the angle inside there is 59.74 degrees. I'm going to write it somewhere over here. 59. Oh, man. Ooh. It is 59.74 degrees. Okay, so if that angle inside is 59.74 degrees, that means that component there is equal to BC cos 59.74. There we go, BC cos, I need to just write it nicer, 74 degrees. And that's BC times the sine of the same angle. So it's BC times sine of 59.74 degrees. Okay. Right, what's the next thing we do? We sum verticals and we sum horizontals. Okay. And as I told you last time there, I normally start with the verticals first, but I'm going to start with the horizontals first. Why? Because if I sum verticals first, I'm going to have AB and BC as unknowns in one equation, which is not solvable. So I'm going to start with solving horizontals first. So I'm going to have BC as an unknown, and that forms, I'm going to have that force and that force as unknowns in my equation, and therefore I'll be able to solve BC. So I'm going to say, let me just do this quickly here. Right. Sum of forces in the horizontal is equal to 0. Okay. So I'm going to have minus 20.56 plus BC sine 59.74. So it's minus 20.56 plus BC sine 59.74 is equal to 0. Okay. Right, so I'll make BC the subject of the formula. So BC is, if I do a quick calculation, I get BC as 23 0.80 kilonewtons. And because it is positive, it means that my assumption that BC is in fact in tension is in fact correct. Okay, so that's going the right way. If I assume this to be in compression, I would got it to be minus. That means I must turn that around and make it a tension member. Right. Am I done? No, I still need to solve for member BA or AB. So I'm going to solve verticals. So the sum of the verticals is equal to 0. Right, so I've got plus 25.90, 25.90 minus BA, which is going down, or AB, doesn't matter, minus BC, cos 59.74, minus BC, cos 59.74 is equal to 0. Right, but I know BC from there, so therefore I can solve BA. So therefore BA, do a quick calculation, and I find BA is equal to 13.91 kilonewton. Ooh. And because my answer is positive, it means that my assumption that BA is a tension member is in fact correct. Okay, so people there, I've solved for the joints. I went to joint B and solve for member BA and BC. Don't just check my answers. Don't just assume my answer to be correct. Check it yourself and see if you get what I do and why I get the natures of the forces that I do. Okay, I'm now going to joint A. As I said, that joint A I would have solved BA, and now I can solve for AC and AF. Okay, I'll see you in the next video.